Hello, my name is Mauricio Reyes Canales. I am a geophysicist at the Alberta Geological Survey, and I would like to take this time to invite you to read a recent publication at the Journal of Geophysical Research titled The Rise, Peak, and Decline of the Seismic Hazard Related to Hydraulic Fracturing Activities in the Duvernay Play, Fox Creek area, Alberta. Um, Before introduce you to the paper, I would like to give you a brief overview of the Fox Creek induced seismicity case. Fox Creek is located northwestern Alberta, Canada, and in recent years has experienced an increase in the number of earthquakes associated with hydraulic fracturing. Fracking in this area started in 2010, and we have detected over 490 events larger than magnitude 2 between December 2013 and December 2020. Approximately 15% of the wells are seismogenic, and we notice that most of the earthquakes occur in one area west of Fox Creek. This area at the same time is divided in two sections based on the hazard characteristics. We notice that the east section has a higher hazard. Most of the large earthquakes are located here in the east section, and the west section, even though has a large number of earthquakes, has a lower hazard, a lower contained in the number of large earthquakes. Something interesting we notice in the Fox Creek induced seismicity case is that the injection volumes from hydraulic fracturing actually kept increasing until 2019, and the number of earthquakes larger than magnitude 3 actually peaked in 2015 and has decreased after. So we see a contrast between increasing activity but also decreasing number of earthquakes, in this case larger than magnitude 3. Using uh, temporal variations of the Gutenberg-Richter parameters, the A and B value, we calculate what is the likelihood to have earthquakes larger than magnitude 4 per year in Fox Creek. As I mentioned before, the hazard peaked in 2015 with more than 90% of chances to have earthquakes larger than magnitude 4. We actually got 3 earthquakes larger than magnitude 4 in 2015. Since then, the hazard have keep decreasing until reaching a likelihood less than 1% by 2020, which again contrasts with increasing activity in the Fox Creek region. Now, what are the causes of this increase of activity but reduction in the seismic hazard? Well, the first one is that the activity have migrated out of the area with more susceptible to induced seismicity towards the west. The other reason is that the east section has been somehow deactivated. There is less hazard in the east section, which controls the hazard in this region. And another key factor is the implementation of the Subsurface Order number 2 by the Alberta Energy Regulator in 2015. Under this order, the operators in the Fox Creek area have to implement a traffic light protocol. So if there are earthquakes produced by the fracking activity larger than magnitude 2, they have to implement mitigation strategies, including pausing the operations, reducing the rates, or skipping stages. If there is an earthquake larger than magnitude 4, they have to cease operations. So what are the key points of this paper? The likelihood of moderate events with magnitude larger than 4 has consistently decreased after 2015. This contrasts with the peak in volumes occurring in 2019. There was a drop in 2020, but we think it's related to the pandemic situation. And this trend of decreasing seismic hazard can be due to targeting areas less susceptible to induced seismicity towards the west, reduction of the seismic activity in the eastern section, which contains the higher hazard, and the changes in the hydraulic fracturing operation strategies implemented by operators. We think that this retrospective analysis of the annual likelihood of moderate events is an effective instrument to study the evolution of the seismic hazard. And thanks for your attention. If you have any questions, you can email me. And again, I invite you to read the paper. Thanks a lot.